Now we move to the second part where we implement an agent using some tools with real API integrations. In our scenario, we are using OpenAI model, and then we call the Tavily API for web search, Open-Meteo for weather forecast, and SerpAPIs for Google Flights results and Google Hotels results. We are implementing this agent or orchestration loop using tracing, safe JSON handling, retry logic, and to support multiple calls, tool calls in one turn. This will allow us to demonstrate all the concepts that we have seen in the slides in the first part of this video. So first, we start with our usual API keys for OpenAI, Tavily, SerpAPI, and then we install our dependencies. Let's start with the dependencies here. Everything work well, and then we import the important libraries that we need here. We get them, and then we configure our APIs. Here, if you notice in this code, we are not checking or returning an error if the API is not available. We are just setting it to none, and we'll see why later in this in the code. And we are creating first a logger here to help us to log all the tool calls that we will do as an observability mechanism on our agent. Start this code, run it, and all good. Then we'll define our utility functions to improve the reliability and control on the agent behavior or on the tool call behavior. For the safe JSON dumps, here we are truncating any response that we get to 200,000 characters in this function, and then truncate for model, we are truncating it for 18,000, and this will help us to shorten the token or the message that will feed back to the model before sending it to the model with a full or uncontrolled size. And then we have the request JSON with retries. Here we are calling APIs, the method like get or post, the URL, the API URL, and then we have the parameters, the timeouts, the number of max retries, and so on. And we are doing this attempting to call the API until we get max retries or we get a success. If we get success, we return our results. Otherwise, here we the response as JSON. Otherwise, we have exceptions and we log our exceptions and so on. This is done. And now we move to define our tools. For the weather forecast, first, we have the city as a name, as a parameter. First, we need to decode this city name into coordinates, longitude and latitude, and then through the Open-Meteo API. And then based on that, we will get the weather forecast. And here we will get, for the weather forecast, only the mean and max temperatures and the possibility of precipitation during a day. And here we see it in the results that we return. And our result is just here we have the location, which is the city name and country name. And then we have the latitude and longitude, and the daily, which are, we have the time, the max and mean temperatures, and the precipitations probability. Is done. And if you notice, we are using our request JSON with retries to make sure that we don't call the API infinitely just in case something happens or errors happens during the call. This is just to control the number of retries that we have. We can go through. Then we have the search with Tavily web search. We have the query, max results, we get 5. And here, if you notice, we are checking our Tavily client. If the API is not well API key, if not well configured, it will give us an error message here, and it will exit the function for sure. And then if everything is okay, we will use the Tavily client with the search function, our query with the max number of results, and then we get our results in this format. Actually, each result will have a title, URL, and a content, and this compact will be returned with the query as a final result in a JSON format. We run it, then we have the flight search with SerpAPI. Again, we are checking if the SerpAPI key is set or not. And then we have the parameters. As you see, we have the engine. We are using Google Flights. Departure, the origin from where to destination, the outbound date, and then the type. It's one-way flight, English US, and then we have the currency in USD and our API key. And here we are using again the request JSON with retries to ensure our retry number is set to maximum 3 just in case something happens with the API. And then we return the results in terms of containing the origin, destination, outbound date, and type one way, etc. This is a query, and return the data that we got um, in our search. Hotel search, same behavior of the flight search. We will just skip it quickly. We have the parameters, the API key with SerpAPI, and then we have the result on the city, check-in date, check-out date, and then the data that we get from the web search. How we define our tools. Now, this is the most important part of this video actually here, to see that each tool is well typed. Each tool is type function, and the function has a name. For example, get weather has a description. Get compact multi-day weather forecast for a city using Open-Meteo. Just to give it the description here. Parameters, it takes type object and properties city, type string, and the city is a city name, for example, Berlin. This is to inform our agent or to get this information to the model so it knows how to call the tool, how to emit or to generate the tool call, the well-structured tool call before sending it to the orchestrator to execute the tool. And we see here we have the required parameter as well. We say it is city. So this is really important to notice here to make sure that all of our tools are well described, well structured, the input, the output, the required fields, and so on. And that goes for the function web search. And here important we see as well, like we have the max results, that goes to 5. For flight search, we are using the origin is string, it is the airport code, destination, same thing. And then we have the date and required origin, destination, and outbound date. Same for hotel search and so on. So it's really important part to pay attention to this tool structure here as we define it before moving on. And we run this cell and let's move on. The tool dispatcher here, once the model decides which tool to call, this dispatcher will get the tool name here as a string and with arguments, and then it will decide which function to call, and it will return the results. We have the raw results, and we have the truncated for model results. So we have the original result that came from the tool and the truncated one in case it exceeds the 18,000 character. Our system prompt here. We are defining our agent, saying that you are a careful travel planning assistant with tool access. Use tools whenever live data is needed. Don't invent flight or hotel availability. Don't attempt booking, payment, or etc. Flight search, always use outbound date in date format, and so on. Here are some strict rules on the date format to tell the model how to resolve some text into a specific date. Then we move to our agent orchestration loop. in which we will have the full logic. We send the conversation to and the tool definitions to the model. We check whether the model requested tools or not. If yes, we execute the tool calls, and then we append the results from the tool and pass it back to the model. And we repeat until the final answer is produced. Here we notice that we have multiple tool calls in one model turn. We trace all the executions, and we have the maximum step control to avoid infinite loops. Let's see this. We have the user input coming for our agent as an input, the model name that we are using, GPT-4 or Mini, max steps is 8, and tracing is set to true. Checking if our client is well configured or not, the OpenAI client. And then we define the message from the system prompt and the user input. Our trace is set to an empty list, and then we move into our loop here until we reach the max steps. First of all, we log that as a step number, and then we start invoking the model with the messages that we had and the tools. And we set the tool choice as auto, so the model will decide which tool to choose and call. First of all, we get the messages from the after the we get the response, and we check if we have the in the message, if it is a tool call, we get the function name and the arguments, and then we request the execution of the tool using the tool execute tool functions that we defined as our tool dispatcher, and we get the results as a raw result and serialized result from this tool dispatcher. And then we append to the traces again the number of steps, the tool that we have called, the arguments that we used, and some result preview with 5,000 characters. And then we append the message here to the messages, and we continue. And this will go until we have the final result. And we see here we return the final answer, tool trace, we have it here, and then the messages, and we return the error messages if we didn't reach a final answer and we reach the max steps, we stop at this level. Let's execute this one, and then we try running a demo. Plan a 3-day trip to Berlin next week and include a quick weather snapshot, flight option from Madrid to Berlin, hotel options in Berlin, and summarize it as a suggested plan. Let's see what will happen here with this execution. Now it's moving between the steps, searching the web, moving, checking the weather forecast, finding flights, and finding hotels. And it's still doing it and taking some more time. And now we have a plan. So, trip to Berlin from March 23rd to 26th. Today is the 17th of March. Next week, yeah, probably this is what it takes, like 7 days later. So the weather forecast here, it gives me from 23rd to 26th all the weather forecast, max temperature, mean temperature, chance of rain, etc., as we requested. Then the flight options from Madrid to Berlin. We have Vueling Airlines, and then we have departure, arrival. We have layover here in Barcelona, apparently, and price, flight duration, and price. Ryanair, Iberia, and so on. And then we have the hotel options in Berlin. This is really live data, and it's real data. It's not a mock data that we can see here. We see hotel names with availability, with some rating, price per night, and so on. And then we have suggested a trip plan. Every day we have a plan to do something and see something in Berlin. So this is really important to see how our agent managed to decide which tools to call at which step and how to do all of this by itself. We can check how this happened, and we check the trace here. And in the trace, we see that the first tool that was called was the web search to resolve what is today's date, so it can take us to the next week. Was really important. And then we get the weather, and then it searched for flight, and then it searched for hotels, and that's it. We don't see any error happened here in the calls. In general, we didn't have any issues in this round of calls. Probably if the system prompt or the user prompt are not well configured or are ambiguous a little bit, it might lead to some parameters issues in the tool calls, and then we might face some errors in the execution, and we'll see it in the trace. That's all in general on how we can build this agent with tool calls. We used a simple agent. We use simple tool calls with simple APIs here. We didn't use any external framework to keep it as native to tool calls, and we will see, and we have seen as well in the previous videos, how we can create tools using LangChain, how we can build our orchestration loop with LangChain as well, and so on. But for this video, for the purpose of this video, I've decided to I prefer to keep it as native as possible without frameworks, so we can understand the concepts more easily and deeply. So what we can do actually is to improve this notebook or this agent that we have here. We can add more tools to check and resolve names and dates and so on. But one of the important things that we can do actually is to improve with caching. So we have caching of our results, and it checks that cache has simple memory on the API calls, to avoid repeated calls with the same parameters, identical parameters, and so on. That's really important improvement that we can take from this. And then the other one is you can test actually in using different data, different parameters to check the tool usage accuracy, missing data cases, check the final answer quality, and so on, just to evaluate your agent with more elements or with more data and parameters. For now, that's it for this video. Thank you again for your time and attention, and I will see you in the next video.